Are you seeing double? It's because I'm about to do the double angle formulae. Sorry, that's just me messing around. I couldn't resist. I like doing all the editing stuff. Right, so you tune into hopefully double angle formulae with trigonometry. So here they are, and if you're lucky enough, you get them in a formula book. If not, then I'm sure you can look them up, or you just got to memorise them. Okay, but here they are, so called because this angle here, 2A, is double that angle there. Just give me a quick example of how that works. So suppose I think of an angle at 30 degrees. Here we go. If I double that angle, I get 60 degrees, of course. Well, what that means is that the sine of that doubled angle, 60 degrees, is equal to twice the sine of the original angle I chose, 30 degrees, cosine 30 degrees. And that's why it's called the double angle formula. And these identities are useful for a lot of equations that you've got to be able to solve, or identities that you've got to be able to prove to be correct. What I want to do in this video is just show you how to derive them, show you how to actually come up with them in the first place. So my examples are worded pretty much like this. Show that questions by using an appropriate addition formula. So this one, use the expansion of sine A plus B to show that sine 2A is 2 sine A cosine A. Right? So typical, maybe 2-mark questions in an A-level exam. So what you'd want to do is first of all look up what the formula is for the addition rule, okay? Because it says use the expansion. So in a formula book it looks like this. Okay? Sine A plus B, sine A cos B plus cos A sine B. So you use that one there. And the idea is that you replace the B with another A. Right, so it reads as sine A plus A. So I'm going to write it like that. Sine A plus A is the same as, okay, I should be using the identity symbol, but I'm not going to. Because I just generally don't. Is that something I should do? It is something I should do. Okay, but in an A-level syllabus we're allowed to get away with it. So what I'm going to do is just write it out exactly as it is, but with A's instead of B's. There we go. And notice those two are exactly the same. Okay? And there's no more to it really. You don't need to write sine A cos A plus and then reverse those to sine A cosine A. You can just write that as the same as 2 sine A cosine A. And I'm just going to put in there A as required. So therefore sine 2A, because I've not explicitly written the 2A bit, however, it's 2 sine A cosine A. As required, as asked for. And that's it. That's how you can derive the first result. I'll step away in case you want to do a screenshot of that. And then the next one. So what you'll notice is with these, the cosine 2A, the double angle formula for that, there's actually 3 different variations of it. Okay, so I've just gone for that one. But you need to know how to do all 3. I'll tell you what I'm going to do is I'm going to show you how to do all 3. But coming up with that one, because that's what the question asked. So here, use the expansion of cosine A plus B to show that cosine 2A is 2 cos squared A minus 1. Okay, so here's the expansion of the addition formula. So we're going to go for the same technique of writing it as cosine A plus A. And that's going to be the same as cos A, because it's to show that, it's best to write it like this. I know you're thinking that's just cosine squared A, but it's a show that, which means you've got to put in the obvious step of working as well. And then remember, it's going to be subtract, and then sine A again. And we're just going to write that as cos squared A minus sine squared A. And what I'm going to do is I'm going to write the left-hand side as cosine 2A. And that gives us our first result. Okay, our first result is there. Let's just get rid of that notification. And what you need to do is try and write it as this. Now, because it's in terms of cos squared A, the cos squared A there is fine. We just got to rewrite the sine squared A. And here we can use the identity. Sine squared A is 1 minus cos squared A. I'm going to put it in like that. And then expand the brackets. And then we get cos squared A minus 1. And then plus cos squared A. And then you can see those two together gives you 2 cos squared A, which is what we want, 2 cos squared A minus 1. And I'm just going to put in there A as required by the actual question. Now suppose you wanted the third one. Do you remember what the third one was? Let me write it out for you. The third one was cos 2a is 1 minus 2 sine squared a. Can you see what you do if you wanted to have that situation? At this line here, you'd rewrite the cos squared a as 1 minus sine squared a. Let me just do that in a different colour for you. So in this line, what you do is you'd write it as 1 minus sine squared a, and then minus sine squared a. No brackets required, but yeah, sounds like Phil Collins' album, doesn't it? No jacket required, okay? But no brackets required. Maybe you should think of some mathematical, musical variations of famous songs, okay, or famous albums. Okay, here, this is my no brackets required. Okay, so I'm not about to go into Phil Collins mode. Probably a lot of you don't know who Phil Collins was. Shame, because anyway, there you go. So cos squared a, 1 minus sine squared a, and then that's just going to be 1 minus twice, 1 minus 2 sine squared a to get that one. So this example shows you how to get all three of those cosine 2a identities. And then the last one, this one here, I'll just change my pen back to the favoured blue. So use the expression tan a plus b. Just remember, all these are just simple 1 mark, 2 marks rather, A-level questions you could get on a part A question, in a larger trigonometric question. So we start off with this identity, and same again, tan a plus tan a. I used to teach someone called tan a. Tan A, you're still there? Have you subscribed? Do you still watch me? Love you, Tan A. Okay, it was great. I tell a story every single year about when I had Tan A in my class. Okay, and my class really just loved situations like this. Tan A, you're a star, Tan A. Hope you're doing well. Okay, drop me a comment. Okay, or if you know Tan A, get in contact with him. He'll love the fact that I'm mentioning him in one of my videos. Okay, I should do it more often. I should do more trigonometry videos than that. Okay. There we go. So here we go. Tan A. Yeah, we had loads of fun when he was in the class. Plus, and again, tan A, and then over 1, and then just don't forget when it's plus there, it's going to be minus there. So 1 minus tan A, tan A. Always have an eye on what you're trying to get as well. We're trying to get that. Okay. And it wouldn't do if we had 1 plus tan A, would it? Because we need 1 minus tan squared A there. And so we've got tan A plus tan A is 2, tan A, and over 1 minus, and that's the tan squared A, which is the result we want, okay, as required. And that's it. Those are the double angle formulae. I'm just going to move away in case you want to take a screenshot of that. Okay. Right, hope you found that useful. Tune into some further videos where I look into doing more things with it, including solving some equations. Okay, thanks for watching. See you again.